All right. And so then this brings us to Newton's second law of motion. And I just couldn't resist. I'm a big Star Wars fan. So definitely had to include the force here. Right. So force equals mass times acceleration. F equals ma, or m times a. So the thing about this right here is that acceleration is a measurement of how quickly an object is changing speed. Right. So that's something that's going to come into play in a second. And so with second law, make sure that you know the difference between speed is just how fast something moves, right? We talked about that before. Velocity, we also talked about that. It's how fast something moves and in what direction. And then acceleration is just a measurement of how quickly an object is changing speed. All right. So what does F equals m times a mean? So force is directly proportional to the mass and acceleration. Imagine a ball of a certain mass moving at a certain acceleration. This ball has a certain force, right? But now imagine we make the ball twice as big. So that's why I have the image of the baseball and a bowling ball there, right? So now imagine we're going from a baseball to a bowling ball, right? It's more than doubling the mass, but we'll just say doubling the mass. But it keeps the acceleration constant, right? So if you have a kid throwing a baseball at you and you have them throwing a bowling ball at you, it's again, the acceleration is constant, but which means it's going the same speed, but it is actually going to be a bigger mass, right? A larger mass. And so F equals ma says that this new ball has twice the force of the old ball, right? Because it is twice the size. Now imagine the original ball moving at twice the original acceleration, right? So you have a baseball being thrown at you by a kid and another one being thrown at you by a major league baseball pitcher, right? Who can throw a ball at like 90 miles an hour. So F equals ma says that the ball will again have twice the force of the ball at the original acceleration, right? So if you double the mass, you double the force. If you double the acceleration, you double the force, right? But what if you double the mass and the acceleration? This is showing you right here 2m means twice the mass, 2a means twice the acceleration, and then equals 4f means you quadrupled the force, right? So doubling the mass and the acceleration quadruples the force. And so what if you decrease the mass by half? How much force would the object have now? And so force equals mass times acceleration basically means that the force of an object comes from its mass and its acceleration, right? Basically how much it weighs and how fast it is picking up speed. And so something very massive, right, is going to have high mass, like this iceberg right here. It's changing speed very slowly, right? Low acceleration, like a glacier, but it can still have great force, right? So if there was a boat in between that iceberg and that island that you see right there where the house is, it would just smash that boat into nothing, right? It would obliterate it, but not because it's moving very fast, but because of the mass of it, right? It is a huge iceberg and it has a lot of mass with it. So even though it's going really slow, it's going to do a lot of damage. And then you have this, right? This right here, it's meaning that, let me go to this, something very small. It has very low mass, like this bullet, right? This bullet doesn't really weigh it. There's not much mass to it, but it's changing speed very quickly. Its acceleration is very high and it can still have great force, right? Something very small changing speed very slowly will have a very weak force. But this is very small and it's accelerating very quickly. And that's why you see that image when it hits that watermelon just explodes, right? Because not the size of the bullet, but because of the acceleration of it and how fast it is going, right? Same thing with the iceberg. If this watermelon was stuck between the island and the iceberg, it would turn it into mush, right? Just because the iceberg isn't moving very fast, but it has a lot of mass to it, right? So mass or acceleration, a high one of those for either one, can come with a lot of force, right? It can provide a lot of force for something. So